Picking up from the earlier one today about it's all in the cleaning, but looking at quite specific areas and looking at the whole issue about biofilms. So you think you've done a cleaning job and there are still some bugs around, and some of these can be quite difficult to actually shift. So I'm going to hand over without any further ado to Paul Browning and from Freeman Hygiene, who's going to talk.
I'm going to try and make this as informal, but also entertaining as we go through this. But before I start, can any of you tell me what a biofilm is? Are we aware of this term biofilms? Don't be shy. Pardon?
Film yeast.
Can't hear you?
Film yeast.
Okay, yes, film yeast. Film yeast could actually populate a biofilm, but in itself, it would contribute to a biofilm, but in itself isn't a biofilm. Now, if you'd like to turn to your next door neighbour and give them a big smile. Now, if you can see your neighbour's teeth, you are looking at a biofilm. Plaque is a natural occurring biofilm, and despite what the toothpaste people would like to tell you, that it's a nasty thing to have, in many ways, plaque is a good thing to have because it protects the teeth from those bacteria that corrode your teeth. Another example of biofilms is in the human gut. And the epithelial cells inside the human gut is coated in biofilms, which stops those nasty pathogens getting into your bloodstream. Now, a few years ago, my wife and I used to live in the Scottish Highlands, and we used to walk over stream beds. And very often I would fall over. Nothing to do with it before you get the idea that we'd been on the amber nectar. But have you ever slipped on a stream bed because of the slipperiness of the rocks? That is a biofilm. Now, we've known about biofilms in the ecosystem, in the environment, and in the human body for a long, long time. But I picked up some information about a year ago now, and I got very excited about this. And I can assure you, folks, that it takes a lot to get me excited these days. This is a white paper that was written by Denise Lindsay and Alex von Holy from the University of the Witwatersrand in South Africa. And they worked in the School of Molecular and Cell Biology. And this is what they have to say about biofilms as they relate to the food industry. And when I say food, and if I use the term food, it's synonymous with cider or milk or beer or whatever, because biofilms are ubiquitous in any food or beverage environment. This is what they had to say. The title of the introduction is A Paradigm Shift, which means we've got to throw away the old paradigm before we can accept the new one. And he says the planktonic cell paradigm does not accurately reflect the growth of bacteria in nature or in the food processing environment. Within the last 10 years, studies have overwhelmingly shown that the association of microorganisms with surfaces is the prevailing microbial lifestyle. Now, this has an impact on cleaning and hygiene. And as Peter has rightly said, I'm really carrying on from my good friend Mark Granfield. I too used to work with Pentasol. It's a very, very professional and a very good company to invite into your business. And what we want to talk about now is this new idea that has been coming through for the last 10, 20, 30 years, that when we start to look at hygiene within our cider production unit, it's not the organisms that are floating around in the rinse water or in the cider, it's the biofilms that we must make ourselves aware of. It's a very complex issue, and I want to introduce you to the reasons why it's a complex issue. They're also invisible, so I'm going to show you how we can find out where they are. How can we identify where a biofilm will be present in our production or packaging facility? And then it would be awfully helpful if we knew how we can get rid of them, because they're tough little beggars to get rid of. First of all, it's a complex problem because of the very nature of the business that you've got. You've got raw materials, people, contact surfaces, environmental air, all manner of things coming into the factory every day. We've got mass production, long production runs, and an abundance of different surfaces. And I keep coming back to this idea that bacteria love surfaces. The reason that they love surfaces will become clear in a moment or two. Now, the problem with biofilms is that we may have poor hygiene, and despite a very robust hygiene plan, we cannot get rid of the infection. And this is because the very nature of biofilms is that they grow to maturity and then they will go and relocate to other parts of the factory. So why are they so difficult to control? Let's just run through the main reasons. They're coming into the factory every day. They grow very fast. A biofilm can attach itself to a surface within minutes. They grow in areas of difficult access. Look at some of the complex equipment that you have to deal with, where you can't get in, you can't get your arm round, you can't get it CIP'd. It gets very, very complex, particularly in meat and poultry production. And despite the fact that I've been to seminars over the last 50 years talking about the hygienic design of plant and equipment, we're still having seminars talking about it as though it's something that we've just discovered. They're invisible, which makes it certainly very difficult until we make them visible. They're resistant to conventional chemical treatments. Mark probably wouldn't thank me for that remark, but it's true. Biofilms are resistant to conventional chemical treatment. And this is something that surprised me. That we believe that we probably are the only intelligent creatures on the planet. We might say that our pet dog or our pet cat has got intelligence because they do certain things. When I say this, it'll do this or that. And that's perfectly true. But have you ever thought that bacteria also have a way of intelligently communicating with one another? Bacteria can speak through sending out messages through molecular membrane transport systems. Now, I'll talk more about that later on, but I'm just trying to stack up a few reasons why these biofilms are so difficult to control. Another problem we have in the industry is how many of the surfaces involved in the manufacture of cider or perry or any other beverage, how many of the surfaces are perfectly smooth? This is a scanning electron micrograph of 304 stainless steel. And the little blips that you can see on the 1, 2 and 3 are showing bacteria still attached to the stainless steel. Now, if you just look at that stainless steel with your eyes, not with a microscope, it would look perfectly clean. It would look physically clean. It would be chemically clean, but it would not be microbiologically clean. It's only when we get to electropolished stainless steel, which is certainly out of the question for most production units, but it's only when you get to electropolished steel where you've got that very smooth surfaces that biofilms find it very difficult to get a foothold. Now, we talk about planktonic bacteria. Don't scientists come up with some words that we don't understand so that we don't question them? But planktonic means that they, like me at the moment, are moving around. And if you have a whole batch of cider, there will be organisms in there swimming around and having a pretty nice time. Easily eliminated with conventional chemistry. Now, this is the paradigm that we've been using certainly for the last 50 years to test whether disinfectants comply with the European suspension test. Microbiologists have worked with free-swimming cells, but I've told you that that is not the preferred lifestyle in a cider production unit. This is what a biofilm looks like. This is a diagrammatic representation. I've got one better than that, so I'm not going to spend too long on this one. And what we want to take from this is that 99% of all the bacteria within your factory are going to be stuck on the surface. 99%. And we've said that they're not easily removed by conventional cleaning chemicals. Now that gives me a bit of concern. I'm not really concerned because I know what's coming next. First of all, what is a biofilm? I think the best definition is it's a population of bacteria or microorganisms, because other things can be involved in a biofilm, but it's a population of microorganisms living on a surface and interacting with one another. If you see all the little coloured blips and blops here, these represent a mixture of different microorganisms. So in there we can have fungi, we can have yeast, we can have protozoa, we've got bacteria, we've got a whole mishmash of different things. And you'll notice that at the top of it, here, this like iceberg, is what we call the actual EPS of the biofilm. Now, all I want to say is it stands for extracellular polymeric substance, which is very difficult to say. So we call it EPS. And what it is, it's a substance which is secreted by the bacteria to protect themselves against harsh conditions. That's what a biofilm's for. It protects the population of microorganisms within that capsule, within that microcolony. It protects them from things like desiccation. It protects them from things like, hey guys, there's not enough food about. It protects them from that nasty peracetic acid that you keep pouring all over me. Do you know that these biofilms can neutralize peracetic acid? This paradigm is about 30 years old. I've been talking now to high-risk food factories, people who prepare ready meals. And we've successfully demonstrated that this product works in those companies that supply the processed foods to the major supermarket chains. And when we start looking, we find biofilm. We've just embarked on a project going around the first generation brewers. I don't like the word micro brewers. Micro brewers, we're only going to be small. How about first generation brewers? Because there might be a second generation of this family doing this when I've gone. That sounds more positive, more confident, more motivating. Whenever we go into a brewery, we are finding biofilms. I was in a bottling plant recently. The whole conveyor looked clean, but we found biofilms. The filler bed had biofilm. The pasteurizer had biofilm. It's ubiquitous. It's prevalent, and once it gets a foothold, it's rampant. So all we need is moisture, nutrients, and many, many surfaces, and we've got the potential for biofilm formation. And here's just a couple of risks as well that we can get from this. This is not just going to contaminate our cider with, the gentleman mentioned film yeast, or it could be acetobacter, it could be lactic acid bacteria, or the dreaded Z, Zymomonas, and if you get that, that takes some shifting, believe me. But we can also get corrosion of plant and equipment. Certain bacteria, sulfate-reducing and oxidizing bacteria, will start to corrode your corrosion-free stainless steel. We get a high resistance to conventional cleaning, and of course, a source of contamination which can spoil the organoleptic properties of the cider. It could spoil it so that it cannot even be sold. Or in fact, it could cause food poisoning, which is even more serious. Now, that doesn't happen very often in the drinks industry. It's more likely to happen in high care food, but we have that potential, and we need to bear that in mind. So what we're really saying is that hygiene is always going to be a risk. What I'm saying to you, my friends, is that if we have a biofilm formation, the risk escalates. Just want to draw your attention to this one. This is a very important slide, and Peter has very kindly organised it, so these presentations are going to be downloadable so that you can look at these after the event. So because I've only got 15 minutes left, I want to go through some of the slides very quickly, but I just want to hang about on this one for a short while. This is the phase of a biofilm formation. I want you to imagine, if you would, there are a few bacteria floating around here. Yeah, look, that could be in cider, it could be in the rinse water after CIP, it could be in the rinse water after doing some hand cleaning. And what these guys are looking for, remember they're intelligent, they can communicate towards one another. And they're looking for a surface that has been conditioned. Now what do I mean by that? What I mean by that is they're looking for a surface where there is a trace of food, a trace of nutrients. Because nutrients, when there's not a lot of it, typically in a rinse after a CIP, there's still some soil left. Not enough for you to bother about from a hygiene point of view, but those materials become absorbed onto a surface by electrostatic effect. The bacteria pick this up, and there they are. I'm sorry about this. I've got a very sensitive button here and a not so sensitive thumb. Once they've started to attach themselves to the surface, they start to produce what I referred to earlier, which is this jelly-like material, which is the biofilm. Now, this does two things. It cements bacteria together, strength in numbers, and it also sticks the bottom layer to the surface. So the biofilm protects, but it also it acts as a glue or an adhesive to stick it to the surface. And the rougher the surface, the more difficult it is to remove. Now look at the bottom. This is taking place within minutes. So you cannot clean often enough in a cider production unit to prevent the formation of biofilms. So we've got to find a different strategy, and I'll come to that in a bit. But notice that within minutes, within hours, we've now got a three-dimensional model, like here. These are microcolonies. It could be single species or multi-species. Some of these may not affect cider production, some will affect the hygiene of cider, some will affect the organoleptic properties of the cider, some will prevent the cider from being able to be sold in the first place. But within hours, we've got this three-dimensional model. And we've got channels, and we've got nutrients coming in, we've got waste products going out. A very intelligent system. And after days or months, through intelligently speaking to one another, metaphorically speaking, hey guys, it's getting a little bit crowded in this flat. It's getting a little bit crowded in this biofilm. So what happens is that the periphery of the biofilm pops open, and now we've got new free-swimming bacteria here, like these ones who started the process off in the first place. They're now going to look for somewhere over here where they can set up a new population. So once you've got one biofilm, you've got thousands, if not millions, potentially dotted around the place. Now, I'm building the black picture for one good reason. I want you to get this into your conscious awareness that this is something that you've got to be aware of. It is not difficult to eliminate, but you've got to understand that it's there. If you're ignorant, and I don't mean that you're stupid when I say that, but ignorance is simply not knowing, not having the knowledge. Now you have the knowledge, you can do something about it. So that's what we want to spend some time on. How do I know that I've got a biofilm problem? Anybody, any ideas how you might think you might have a biofilm problem? What would be the first indication? Okay. Unexpected spikes in bacteria counts. In other words, you've got a very robust cleaning program. You've got a good company in who's trained your people to clean in the most effective way. The methodology, the documentation is all world class. Yet you're still getting infection and you don't know why. These spikes are non-uniform in terms of distribution, time and space. In other words, there's no logic to it. You can go for a whole week and everything's okay, and then you get a high count. Maybe in the filler, maybe the pasteurizer, maybe the conveyor. It could be in a fermentation tank, it could be a fitting on the tank. You try to upgrade your disinfection program, but that doesn't work. colleague of mine working in a high-care meat processing factory told me the story where, because of biofilms and because they were ignorant of the presence of biofilms, they started to expand the use of peracetic acid, and they spent another £20,000 that year on extra peracetic acid, and they still had the problem because they didn't know what the cause of the problem was. They were dealing with effects. What we've got to understand is we've got to deal with the cause of it. Traditional sampling methods do not detect contamination, but I still have problems. In other words, if you have a lab or if you send your products off to a laboratory for microbiological analysis and it's coming back saying that you've got an infection, then you can understand that. But if it comes back to say that you haven't, but you're still getting the infection in another part of the production unit, you just can't put any logic to it. So unexplainable high counts, unexplainable outbreaks. What we want to do now is to say, well, how can we find out where these biofilms are? Some time ago on television, one of the toothpaste companies was advertising, you can find out where plaque is on your teeth by using disclosing tablets. You remember that, any of you? And it coloured your teeth if you had biofilm. Well, it's still around. There are swabs, sponges, contact plates. They're not reliable. Now, remember what I said, all this information is available on the website from this organisation, so I'm not going to spend too much time on this because I want you to see something which is pragmatic, something that you can do about this problem. But contact methods are not reliable. And I'll just say this, that if you remember that model we had of the biofilm, the bacteria, the microorganisms are kind of bedded down, and above them is this jelly-like substance. When we take a swab, we're not harvesting the bacteria underneath, we're just sliding across the top of the biofilm. We're harvesting a lot of biofilm and maybe a few organisms, but it's not a relative sample. It's not a representative sample, I should say, of what lies beneath. So you cannot sample biofilms by contact methods. So this is the thing I was talking about. You chew one of these tablets, and if your teeth aren't clean, they go purple. These two at the bottom. Anyone using ATP in production? Yeah? Okay, that's good. ATP will not pick up biofilms. Sorry to say that to you, but ATP detection will not detect biofilms for the reasons I've just said. It relies on a physical swab, and the swab's going to pick up a lot of EPS, a lot of that jelly-like gunge, which protects those organisms that you're trying to harvest to find out if you've got infection at that particular sampling point. So it's my responsibility and delight to introduce you to this method, which is called Biofinder, which makes the invisible visible within about 30 seconds. In ambient temperature like this, on a day like this, biofilm can be detected in about 30 seconds. In a cold room, it can take up to a minute. And this relies on a very simple chemical concept that's been about for at least 100 years. And it's the fact that bacteria or microorganisms in a biofilm produces immense amounts of an enzyme called catalase. And within the formulation of the Biofinder, we have hydrogen peroxide at very low level. Hydrogen peroxide and catalase produce oxygen. So we can actually detect a change in the application of Biofinder, which also contains a colorant. Now, it will make more sense in a moment or two, but this is an orange-coloured liquid that generates microbubbles when it detects catalase. And film yeasts, Acetobacter, lactic acid bacteria, and the Zymomonas, the big Z, all test positive for catalase. So if you want to know if you've got any cider spoilage organisms within your production and packaging unit, this will tell you. Fast acting, will not stain, doesn't leave residues, easily rinsed off, easy to use, no special equipment, complement of standard microbiological controls. It complements, it doesn't replace ATP, because this is a qualitative test. You've either got biofilm or you haven't, but it doesn't tell you how much you've got, it tells you you've got enough to get concerned enough to get rid of it. This is what it looks like. I don't have any examples of biofilms in cider production. I have one or two from the breweries, which is where we're doing a lot of work right now. But this is typical. Here we see the orange viscous liquid, which is sprayed onto this bolt, and where it turns white, that is because we have a biofilm positive reaction. Remember what's happened? The catalase has reacted with the hydrogen peroxide to produce oxygen bubbles, which then bleaches the natural orange dye within the formulation. Talked about rough surfaces earlier on. This is a chopping board where a knife has been used to chop meat, and you can see the score marks where the knife has cut into the surface of the chopping board, and it's within those valleys that we get a positive reaction with Biofinder, indicating that we've got a biofilm problem. I can assure you, ladies and gentlemen, that if you was to look at that chopping board, which had been cleaned, it would look perfectly clean. This is a tube connection. That is a very, very positive reaction. That's the kind of thing that we find on fermenter fittings, on the valves. Generally speaking, the inside of a fermenter, for example, should be biofilm free, but one thing that really did startle me a few months ago when we started looking into this very seriously is that 360 degree static spray balls in a fermenter can grow biofilm on top. Check the connection of that spray ball. It should be a loose fit. It's a loose fit so that certain detergent can go up the spigot to clean that as well. I've seen spray balls welded onto the spigot, and that's a blind spot, and that's where the biofilms will live. Not forgetting cleaning equipment. This beauty here was just 48 hours old, and the cutting edge of that squeegee was that colour and looked clean before we applied the Biofinder. So looking at cleaning equipment, I think, is very, very important, not just to look at the main processing equipment and packaging and stuff like this, but also to look at cleaning equipment as well. So what do we do now? There is enzymatic and surfactant technology available that can dissolve biofilms. We can use our conventional detergents in many cases, but it will depend upon where the biofilm is laying. Sometimes we can remove it by mechanical action, just a scrubbing brush or a scouring pad. Enzymatic products are specific for EPS on biofilms, and I've seen this on a company in this country that has got global presence, massive biofilm infection on their conveyors, which was removed literally within 30 seconds. It literally fell off because enzyme solubilizes the biofilm very, very quickly. Some advantages there of enzyme technology. Again, I'm going to ask you to download this and read this through for yourself because my time is coming to an end. So, how do we implement a biofilm detection and elimination program in our factory? The first thing we do is to do an audit to determine the location of biofilms. The second thing that we would do is decide on the optimum treatment protocol. Then we would implement a treatment program and monitor the results. The lengthy part of this is step one, to do an audit. We go into factories and we will demonstrate how to use the Biofinder, and then the customer will then go on to do it for themselves with our technical support. But we've got to find out where they are. We've got then to decide how are we going to remove them. That's the treatment program. And then step four, once we're happy that this is working and we've eliminated biofilms, we want to integrate that program into the company hygiene plan and then train people how to use that effectively. So I apologise for getting through that rather swiftly, particularly on a topic that for some of you may be quite new. But I'll be happy to answer any questions you may have to the best of my ability.
Well, thank you very much, Paul. And just a couple of minutes for questions now, before we have a brief break before the next presentation. Anybody got any quick questions for Paul? Obviously, Paul will be around to spend some more quality time with you as you wish. Anybody any quick questions at the moment?